All right, so today we are going to talk about rationalizing the denominator of a fractional numeric expression. And it sounds super fancy, it's not that bad. Okay, so start with some review of multiplying. So pause the video, do all the problems. So here we get 40 minus 15i plus 16i minus 6i squared. 6i squared it's negative 6 times negative 1, so that becomes plus 6. Combine that 40 with 6 and you get 46. Combine those middle two together and you get plus I. And that's it. Number 2, again, just start by FOILing out. Negative 24 plus 28i plus 56i minus 63i squared. Again, that 63i squared becomes a plus 63. Combine that with negative 24. That gives you 39. And then 56 plus 28, 84i. And then the last one. Now this one I usually skip steps with because it is like that whole idea of the dots. So the middle terms are going to end up canceling. So negative 8 times negative 8 is 64. Negative 11 times negative 11 is 121 I squared. So that becomes 64 plus 121 is 185. If you want to multiply the whole thing out, you can, but you're going to get 88i minus 88i. They're going to cancel. Okay. What does rationalizing the denominator of a fraction mean? So remember, a rational number is something that can be written as a fraction. An irrational number can't be written as a fraction, and the most common example of these are square roots that we don't know. So for example, square root of 2, square root of 7, anything like that. So rationalizing a denominator means rewriting the fraction so there is no square root in the denominator. There's this rule, it's not like a hard rule, but there's this rule that you're not supposed to have a square root in the denominator of a fraction. So this is that process. So you may have learned this last year, these at least, with in trig, where you're rewriting your roots. So to get rid of square root of 3, all we do is multiply it by itself. Because what's the square root of 3 times the square root of 3? Well, that's just the square root of 9. And then what's the square root of 9? 3. Done. So you just multiply the denominator by the radical. If you square a radical, it goes away. But you can't square a fraction. So we just multiply it by itself. So try the other ones on your own then. So root 7 times root 7. Root 77 over 7. Done. All right, a little harder. We're going to multiply by root 2. And now on the top, though, we're going to have to distribute. So we get 4 root 2 plus root 10 all over 2. You can leave it like that, or if you want to simplify, 2 root 10 plus root 10 over 2. You cannot divide that 2 into the 10, though. You're not allowed to divide it into a square root unless it's also a square root. And number 4, again, multiply by root 3. So we get 6 root 3 minus 2 root 30 all over 3. And then you want to ask yourself, can we simplify 30? Is there a perfect square that goes in a 30? There's not. It's just 1, but that's not useful. It's just 5 and 6, so you're done. That's it. So those are the easy ones. So now let's get into the harder ones. Now think about this process is just like what we did with dividing imaginary numbers. So what did we do there to get rid of the I? We multiplied by the conjugate. So that's what we're going to do here. 7 minus root 2 7 minus root 2. So we're just going to distribute. So we get 21 minus 3 root 2. Now that denominator, again, we're FOILing. 7 times 7 is 49. The middle two terms are going to cancel. I'll write it out the first time. So we get minus 7 root 2 plus 7 root 2 minus the square root of 4. Those 7 root 2's goes away. The square root of 4 is 2, so minus 2. So our final answer is 21 minus 3 root 2 all over 49 minus 2 is 47. So I usually skip that don't do all that work. It just takes up too much room. All right, so pause and try the other ones. So 6 minus root 11, plus. Don't forget to change the sign. 6 plus root 11. So when I distribute, I get 30 plus 5 root 11 over, so I get 6 times 6 is 36, minus root 11 times root 11 is 11, 30 plus 5 root 11, all over 25. Now this one I can simplify. I can divide all of those by 5. So we get 6 plus root 11 all over 5. Definitely should have made this into 2 slides. All right, try the next one. Same idea. 12 plus root 15. I keep forgetting to change the sign. Minus. Always change the sign. All right, so I'm trying to write small. 12 root 3 minus root 45 all over 12 times 12, 144, minus 15. Now, this one's a little harder because root 45 can simplify. The square root of 45, right, 45, is 9 times 5, so that's 3 root 5. So 12 root 3 minus 3 root 5 all over 144 minus 15. I could do that in my head, but really tried. 129. And that's our answer. Okay, because, oh wait, we can divide by 3. No! I am so out of room. I'm sorry, guys. This is terrible. I apologize. 12 divided by 3 is 4. Minus 4 root 3 minus root 5. That's a minus all over 43. Now that's the final answer. Ugh. Okay. Last one on this slide. So multiply by the conjugate. 1 plus root 21. 1 plus root 21. I'm going to try to write it over here so I have more space. So 8 root 7 plus 8 root 21 times 7 is 147. All over 1 minus 21. Now 147 does simplify. I can actually tell that because when I multiply root 7 and root 21, there's a 7 in there. So it's going to be 49 and 3. So we get 8 root 7 plus. So we have 8 times the square root of 49. Square root of 49 is 7. 7 times 8 is 56. Root 3 all over negative 20. I can divide everything by 4. So that my final answer is 2 root 7 plus 14 root 3 all over negative 5. I don't think that's that they're hard. They just take, you need more space. Don't cramp it like I'm. Okay, so now here are a couple more, more difficult. So pause, try it on your own. All right, so the denominator is 2 root 5 minus 5 root 2. 2 root 5 minus 5 root 2. So now these are harder. We're going to have to actually FOIL out that top. All right, so let's see what we get. Negative 2 root 5 plus 5 root 2 plus 2 root 25. We're gonna simplify it, but minus 5 root 10. All right, so let's simplify just that numerator. So this becomes 2 times 5, which is 10. So on the top, I get negative 2 root 5 plus 5 root 2. I'm going to put net minus 5 root 10 plus 10. And we can't combine any of that. That's it. We're done there. And then on the bottom, 2 root 5 times 2 root 5 is 4 root 25 minus 25 root 4. Now, if you can figure that out in your head, go for it. This becomes 4 times 5, which is 20. And then 25 times 2, which is 50. So, my final answer, negative 2 root 5 plus 5 root 2 minus 5 root 10 plus 10 all over negative 30. Whew. All right. Try this next one if you made a mistake, try again. All right, I think this one's a little easier. No, I don't think it doesn't have coefficients, but we're gonna have to simplify. So root 7 plus root 2. So let's see, FOIL that out. So that's 1498. Yeah, so that's root 98 plus root 28 minus 2 root 7 minus 2 root 2. And then the bottom we get 7 minus 2. All right, 98 is 49 times 2. So 7 root 2. 28 is 4 times 7. 2 root 7. Minus 2 root 7 minus 2 root 2. So these middle two cancel. This is interesting. Those cancel, and then those combine to 5 root 2. All over 5. We get root 2? Seriously? How? That's crazy. I don't know why that happened. That's cool. That's a cool answer, though. All right, last side for this, and then we're going to work on some eyes some more. All right, 1 plus 4 root 3. 1 plus 4 root 3. All right, see if I can FOIL this out without being a disaster. All right, so that's negative 2 root 5. Negative 8 root 15, 5 root 3, 20 root 9, all over 1 minus 16 root 9. Be careful there. 4 times 4 is 16, so you do have to simplify the denominator a little bit. Root 3, so that's 1 minus 48. So the denominator is negative 47. And then let's see on the numerator what we can do. So none of these combine or simplify, but 20 root 9, that's 20 times 3. So that's negative 2 root 5 minus 8 root 15 plus 5 root 3 plus 60. So that is your final answer. Alrighty. Last one. Let's see what happens here for this one. See if anything fun happens. Root 2 minus 3 root 5. Root 2 minus 3 root 5. Oh, we're going to have to simplify. I can see that because I'm going to multiply 10 times 5, which is 50. All right, so 2 root 2 minus 6 root 5 plus root 20 minus 3 root 50. So that's the top, all over 2 times 2, so 2 minus 9 times 5. 2 minus 45 is negative 43. So the bottom is going to be negative 43. Now let's look at the top. So we can simplify the 20. That's 4 times 5. And then the 50 is 25 times 2. Okay, so we're going to be able to simplify again here. So we got the 2 root 2 minus 6 root 5. Square root of 4 is 2 root 5. And then 5 times, this is the square root of 25 is 5 times 3 is 15 root 2. So then we can combine those together, negative 13 root 2. And then the 6 and the 2 gives me negative 4 root 5 all over negative 43. That was a 13. And that's it. I say that's it, like no big deal. I know there's a lot to keep track of here. Okay. So remember when we were dividing, we were dealing with I, but remember I is a root. So you also need to rationalize the denominator of an I, because an I is a root. I is the square root of negative 1. All right, literally, here's the great part. The directions for rationalizing the denominator and dividing, it's literally the same thing. There's no difference between dividing and rationalizing the denominator. So we've actually done this. So just go through and just practice, because we've done all this. So I in the bottom, 2i over 8i squared, 2i over negative 8, 2, whoops, just kidding, I over negative 4. That's it. You could also simplify the numbers first if you want. Like here, I could start by making it negative 3 over 2, and then do the I. So negative 3i over 2i squared, which is 3i over 2. And then this one, again, you can divide everything to start if you want. It doesn't really matter. I'll try that. Divide everything by 2. 3 plus 4i all over 2. I multiply everything by I. So we get 3i plus 4i squared over 2i squared. Replace my I squareds with negative 1. So 3i plus 4 times negative 1, 2 times negative 1, 3i minus 4 over negative 2. So now again, I'm good with you leaving it like that. If you're having, depends on the teacher, IXL, they do make you rewrite it in the form of a plus bi. So that would be 2 minus 3 over 2i. It's just taking that and breaking it up. All right, last slide. Again, same thing we've been doing, nothing new here. Pause the video, try it on your own. Negative 1 minus 3i, negative 1 minus 3i. So we have negative 8i minus 24i squared all over 1 minus 9i squared. This becomes negative 8 plus I, just kidding, space, negative 8i plus 24. This becomes 1 plus 9, which is 10. And then I can divide everything by 2. Negative 4i plus 12 all over 5. And I'm going to leave it like that, even though some math teachers might judge my video. I don't care. All right, last one. Conjugate 3 minus 4i. A little more distributing here. All right, I'm going to write little. Negative 12 plus 16i plus 30i minus 40i squared. That's FOILing out the top, multiplying out the binomials. 9 minus 16i squared. So I get, this becomes a plus 40. 40 minus 12 is 28 plus 46i over, this becomes 9 plus 16, which is 25. And you can't do anything there, and you are done. All right, that's it. Homework. Enjoy your vacation. I'll see you guys later.